Alright. For the moment. I am both live streaming this and taking a video of it. But first thing I'm gonna do is get my hair out of the way. I've got a little hat. I need to find my phone. Ow, 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 ow. Alright. So. I'll put this back on. Make lots of noise. So, the deal is, I have never soldered before, and I bought a keyboard kit for, well, from a place called Massdrop, and I got the Ergo Docks. And that requires soldering, and since I've never soldered before, I figured I'd start with something different that would teach me how to do it, and teach me how an AM/FM radio works at the same time. It was just something I found when I was browsing along on Amazon, so I figured, why not? Let's see. I bought this from Amazon. I've got price listings on my website. But I got this kit. I've got a flimsy falling out of place magnifying glass to check the soldering joints after I'm finished. I've got an X-Tech multimeter. And this I got based on a review by Dave Jones of EEV blog. So I got that so I can test my readings. Well, test to see if my stuff works. The soldering station I've got here is, oh yeah, here's the manual for it. Mini multimeter. That and the Heiko or Hako, probably Heiko FX888D soldering station. That's what I got. I've already read these manuals. If you ever buy something that you haven't used before, like I have never used a soldering station before, you should probably read the manuals. And the soldering station also came with this plastic sheet covered list of the tool tips, the soldering tips. So that's kind of nice. Put that over there. Hopefully I won't need that right now. Actually, I'm going to want to set up the actual soldering station. So my camera wasn't actually taking video during that. I'm gonna start over. First thing is first, I put a hat on, keep my hair out of my face and out of burning range from potential solder stuff, whatever. I've got safety glasses so that should I be particularly derpy with soldering, it won't get in my eyes. I'm hoping that's not the case, but you never know. I've got a magnifying glass to check the soldering joints. I made this workbench because I didn't have one before. This particular material is HDPE, high density polyethylene. Hopefully it'll do what I researched that I hoped it would do. Heat resistant and not particularly electrically conductive. Let's see. So I mentioned read the manuals before you do anything that you have not done before. Soldering, I've never done it, so read the manuals. And I'll probably do a better review of everything when I'm soldering my keyboard. But for now, I'm gonna find out who just texted me. My mama! Cool. Let's see. Yes, I've got Multimeter X-Tech reviewed by Dave Jones on the EEV blog. Very enthusiastic Australian. I'm particularly fond of those videos. So, AM/FM radio kit model AM/FM 108 CK Superhet radio contains 2 separate audio systems, IC and transistor, by Elenco. That is what it is. So, I've already read through a fair portion of the manual, and it says keep the box. So, again, read the manual. This is obviously, you know, assembly and instructions. This is basically an educational soldering kit. So you're gonna be reading the manual anyway. But in this case, ooh, look at that pretty back. I didn't actually look at the back yet. Fancy. Anyway, don't get rid of the box. I'm gonna set it off to the side. Alright, so... oh, thank goodness. I've also got my 9-volt battery. Woo-woo. Put that off to the side as well. Alright, so... this... I've actually got a fair amount of space on this desk. I'm gonna move things out of my way a little bit more. camera. Hey, that works. Okay. Okay, so I've got, what is this? Lead-free solder. I'm probably gonna need that right away. Let's see. The AM/FM radio project is divided into two parts, the AM radio section and the FM radio section. At this time, only identify the parts you will need for the AM radio as listed below. Do not open the bags listed for the FM radio. A separate parts list will be shown for the FM radio after you have completed the AM radio. If you are a student and any parts are missing or damaged, blah blah blah, don't call the person you got it from, call the company. Basically. This one actually isn't labeled for one or the other, but close enough. Alright, so not only do I not know anything about soldering, apart from the videos that I watched the other day, I don't really know a whole lot about electrical circuits or circuit boards. I know enough to kind of understand certain things, but it's been a very long time since I was in high school, so I really don't need these right now. Alright, it goes over the different color codes of resistors. So let's open this up. AM radio parts. Put that off to the side. We got some test points, little screws, foam. Ah, yeah, okay. The foam is because of transporting. I don't even... Tube. I don't know what this is. Wire. More cardboard. Another little circuit board. That's a transistor audio amplifier. A little sticker. This is magnetic. That's the speaker. Stuff. Oh, it's even got it listed on there. More parts. More parts. More parts. A lot of this is, like, super tiny. Like, you have to be able to read this stuff. I can read it, but it really probably helps to have something to increase your visibility that doesn't reflect the light that you're using. 151, 103, 103, 203, 203, 203, 203, 203. So, let's see here. This is the parts list, and it has little check boxes here for stuff to make sure you got everything. Pardon me, I'm thirsty. Alright, so we've got one 10 ohm 5% 1/4 of a watt resistor. At least I think that's what that means. I think it says it over here. I don't know. 14W. That's what it says. So let's see. We need one R45. There's one right there. I'm gonna go ahead and check that off. R44. It says 2. So I would expect to find 2 R44s and 2 48s, but I don't know if that's what it means. It's not on that either. Well, that one has 4 different listed things. That one does. We'll assume this means 144 and 188 or 48, whatever, because that's confusing. But yeah, I got both of those. 48, 44, 38, 43, 50, 51, 49, right there, 41, 37, 42, are 33, 36, and 46, 40, 32, 35, 39, 31, 47, and 34. Yeah, all that. Boop. Volume S2. Diode. What is volume S2? Is it this thing? Is this a resistor? Hell if I know. It's got an RB. This would be 50K. It says 50K on it. And this is in the picture for resistors on this side. So, potentiometer or potentiometer switch with a nut, metal washer, and plastic washer. Nut, metal washer, plastic washer. And a little knobby guy. Ooh, I forgot to go over the most important part of this. Oh no, copyright 2012. Where did I see it though? I could have sworn that I saw some kind of copyright from here it is. It's on the actual board itself. Copyright 1989, 1998. So that's cute. That's cute. Anyway, I've got all that. I'll have to pretend that I know what that is. It's in the... These things were all listed. Well, there's a couple things on here that weren't. That diode, that capacitor, and that capacitor that weren't there yet. But I've got that. I didn't even go over to make sure that these were all the correct lines. This is gold, purple, black. They all end with gold. They're all supposed to end with gold. The other one has orange on the end. I don't know if I should trust these. Brown, black, black, gold. Gold, black, purple, yellow? Gee. I hope these are correct. Otherwise, that'd be Not cool. What? Looks like gold. It's just on backwards. Okay, so yellow, purple, black, gold. It's on backwards. That's cool. Brown, black, brown, gold. Brown, black, brown, gold. Gold. That's good. Brown, black, brown, gold. Brown, black, brown, gold. Yellow, purple, brown, gold. Yellow, purple, brown, gold. Brown, black, red, gold. Red, 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 gold. Those look orange. Those are definitely orange. It says yellow, yellow, red, gold. Oh, I'm sorry. That is orange. It's just yellow orange. Alright, well, orange, orange, red, gold, I guess that's... Comparing it to that color, it's definitely orange. Whatever. Orange, orange, red, gold. Brown, black, orange, gold. Brown, red, orange, gold. Red, purple, orange, gold. Orange, white, orange, gold. Green, blue. I guess there's blue. Orange, gold, and brown, black. Green is supposed to be on there. Oh, it's on the other side there. It's on the other side, but there's green and then gold. Okay, so those are all correct, even though they're switched up in directions, and it's probably going to be important which way these are facing. Hopefully this tells me. Otherwise, I might be a little bit screwed. And that's what the multimeter is for. Even though I don't remember exactly how you use a multimeter in that particular sense. Yellow, purple, black, gold. Brown, black, brown, gold. Brown, black, brown, gold. Orange, orange, brown, gold. I guess that is brown. Orange, orange, red, gold. Yellow, purple, yellow, gold. That's good. The diode says 48 on it. Pretty sure. Capacitor over here says 102. And this guy says 47 U. I forget what the U stands for, but it's pronounced mu. Micro. The mu means micro. Okay, so 47 micro farads. Farads. Microfarad. Hopefully I'm pronouncing that correctly. There's pico. Itty bitty tiny farads. Picofarads, nanofarads, and microfarads. P, F, N, F, and mu F. Says it twice on there. 25 volts. Okay. Let's go back to this. Okay, so I've got all the resistors, including this odd thing that I didn't think was a resistor, but it turns out to be a resistor. Capacitors. We've got C30. 46 is this guy. Put that out of the way. 46, 31, and 38. 31 and 38. 29, 33, 35, 36, and 37. Okay, I think I understand. These are both the same thing, obviously. So there are two total, but their symbols encompass both of those things. Even though they are separate objects, they are part of that one quantity, so that makes better sense. Try to open this bag without damaging anything inside of it. Okay. Hey! Killed 2 birds with 1 stone. Almost. There's still double bag. I'm gonna keep these in this bag at the moment, but I'm gonna open it. Alright. Symbols for these are underneath them. I'm gonna lift them up. So we've got whatever this thing is. It's heavy. When I looked at it in the picture, I was like, what is this little cigarette thing poking out of this? What is this? Coils. Ferrite core. Coil. Plastic holders. Color dot. What is that? There's another part, isn't it? Not that. Put that off to the side for now. We're still going over these. Coils. Magic wand. Ooh. I did found a dial knob and a pot knob. I don't know. I guess. Earphone jack with nut, that's in the other thing. Radio stand is actually on the table over there. Speaker. Header, male, 4-pin. Oh, that's what those are. Brass core and iron core. That's what these are with the shrink tubing there. So there's these. I don't know what a magic wand is, but I've got it. Got all those ones. C24. C44. Dyslexia. Yep, one of those. 28 and 45. There it is. 32, 40, 41, and 42. All those. 47 is this one. 34, 39, and 43 are in here. And a C1. Tuning gang AM/FM. Variable. It's not in either of those ones. Those are all accounted for, minus the diode, which is actually right there. D5. That's one of them. Where's D4? not actually listed. There's only one diode on there. Here's the earphone jack with a nut. Is that a nut? It's got threading on the inside of it. Alright, let me see here. Tuning gang. Oh. This is this funky looking dude over here. Actually, I've got some stuff I can put things in so they don't go places. I'm assuming this is the, oh, here it is. Knob, dial, knob, pot. I do have both of those. We'll keep those together in the bag. A little sticker for the dial. And 2 little bitty screws. Two little bitty screws. That M, I believe, stands for metric, but it's got a metric value right there. Somebody's car is going off. Here's the gang. I'll just put that in there for now, so I can check that off. Where is that? Tuning gang, AM/FM. You know, I think somebody is just manually beeping, because, I don't know, they feel like being an asshole. Let's see. PC board, transistor, audio amplifier, that's little tiny guy over here. The main board is here. Battery holder is over there. I've got some lead-free solder. Label AM/FM, I'm pretty sure that is the whatever it is. Thingy. This thingy. If you're wondering, I've got my webcam up here, and I've got it facing normally, like it's a normal webcam. It's just flipped both vertically and horizontally, so that anything that I can read normally, for you it's exactly the same way. Like, it's from a different perspective, but you'd be able to read it without like doing whatever. Anyway, speaker pad, that should be some little, oh, this is this cardboard thing, I guess. That's just for the webcam, of course. There's the speaker pad. I'm gonna hide that over there with a speaker. Oh, no, that's open. Okay. Stick that in there. Oh yeah, it's it looks like a bit of cardboard. I was like, oh, cool, cardboard. But no, it's this little foam stuff with peel off sticky. So there's sticky stuff on this side. That is what that is. Put that off to the side because I don't need it just yet. 22 AWG insulated 8 inches. This, I'm gonna hazard to guess is that, but I'm gonna look at it here. It says AWM 1007 22 AWG 80 degrees Celsius 300 V, I'm assuming that's volts, VW-1 E228840 CRC C. Oh, I have no idea what that says. I don't know. That's what this is for. It's poking up my nose while I'm trying to do this. 9CL? I don't know. 9LE? I don't know. Very tiny. I don't know. Little bitty. That is indeed the 8-inch wire 22 AWG insulated. Putting that off to the side. Checking it off also. Test point pin. 12 of them. Put that. We've got in here 1, 2, 3, 4, 5, 6, 7, 8 in here, and 9, 10, 11, 12 in there. I'm not gonna open that yet. I'll open this one. Beautiful large bag for this tiny, tiny amount of parts. Put that in there. I guess I will open this. Take out the little board. And I'm totally gonna mix the test points because they're the same thing. I want to figure out what these guys are. One dropped in there. Okay. These things. N3906338. These, I believe, are semiconductors. This is 3904. 3904. There are 5 of these. One. That is something different. 3906. That's a 3906. That's a 3904. This is also a 3904. This is not. Oh, this is the other diode. I found it. I'm gonna put it with this other one. I'll cut this open. It's got a dark side on one side, actually. Let's see what it says. Eight. 48. I think it's also listed the same as the other one. This says 48 on it. I'm gonna do that. Alright. So those are 904s. This is also a 904. But not. That is. And that is. So we've got 5 904s, which is how many we're supposed to have, which is good. Check that off. I found the 2 diodes. Oh, it does have, I did notice a 48 on it, but it lists, it should be more readable. It says one N4 148, which is indeed N, or 1N4148, and the other one looks similar enough. I'm not gonna squint. Oh, these are these colored things. These have different colors on the ends of them. Red. Make this a little bit easier. Okay. We got red, we got yellow, we got silver, and we got darker silver. We'll just call it black. These things, I'll put those in there. And we've got a switch. Boop. I'm gonna just guess this is the AM/FM switch. This and this. Slide switch, speaker pad, test point pin, label AM/FM, semiconductors, transistors, that's what those are. Color dot. Coil. Okay, so where does it say coil? Coils. We've got, it is black, so yeah, we've got all of those. L4 AM antenna with holders. Where is that? Is it still in the box? Does the radio stand? It's not in the box. I know it was in the box. Is it underneath something? Let me finish checking these things off. This is this LM386N. LM386 is what it says here. IC some 13H01 or 01WS, including its mate on the other side there. Where does it say this? Socket, 8-pin. That would be the socket right there. Header male 4-pin. That's not that. We found the test point pins. I found a plastic washer. Nut. M1.8. Three. I'm gonna have to guess it goes with this as well. For the battery holder. For the battery holder? Yeah, I guess. There it is. Did I check that off? Check. Yeah, I did. I'll put that in there. I guess the FM parts. There's the what's it called? The thing you use to whip people when you rip it off of a radio, really. Here's another bigger one. That goes with one of these. I forgot I could be listening to music. Oh, this is listed over here. Integrated circuit. Pop that in there. I don't think I should need that right now because it doesn't say. Then let's see here. We've got SH050. Okay, that might be a J. No, it's S. It's definitely an S. It's also an S. It says J over here. So I hope that's not too big of a deal. Male header pin, 4-pin. There are 2 of these, and they're not actually labeled, so I'm gonna assume those are the male header pins. Oh, I found the speaker, not sneaker. The earphone jack. That is the jack with the nut. Okay. Put that in there. Put those in there. I'll just put those in there too. This says... Did I not? I guess I didn't. Did not merge those. Okay. So this one says 2N3906. One of those. Obviously, this is the boring part. Checking to make sure that your parts are all correct. And it's just these two so far in particular that I've got issue with. It says here JE 8050 and JE 8550, where I've got SB or S8. Now that'd be the 8S8050, which matches up to that, except for the JE. What does JE stand for? I don't know. On this one it says D331. The other one it also says D331. This also is an S in front of it. 8550. I'm not going to take too much quarrel with it. I'm going to assume that they've given me the correct parts. Hopefully that is the case. AM antenna with holders. I guess this is an AM antenna, according to this. Antenna assembly, so yeah. Antenna with holders. It's... I didn't know that's how they pick up the signal for the AM. I've never taken apart a radio before, but where is this? Delicate little wires. So apparently this is what's used to pick up an AM signal. We'll find out. But that's the AM antenna. Alright. Stuff this in one of these things. Okay. Anything else? We've got all our resistors, and I checked that they were all correct resistors. I've got all the capacitors. I did not check if they were correct. Let me check again how to read this particular first digit, second digit multiplier. And the multiplier is that. So this one says 151, so that's 151 is 150. That's correct. 103, these two are 103. 103, it's, I already got that there. 10 is 10, 3 is thousands place, so 10,000. Oh geez. Okay, so 151, tens place. 150. Starting in picofarads. I said 3. Difference. Obviously 0, like if it was 1 0 0, it would be just 10, or technically could be 0 1 1. It'd be the same either way, but that would be a 10 picofarads. once it gets up to the hundreds place. So if this was 2, that would be 10 in front of that, isn't it? My brain stopped working correctly, I think. The rest of them are all in microfarad. Yeah, micro. Oh well. Okay. 103, 10, third place, 10,000, 10, 100, 10, 10. I guess that's one way to think of it. 10, 10,000. 10, 10,000 is 100,000. Whatever. 103. Yes, and yes. 203 is same thing, just one more. We got a bunch of those. 473, same deal. 104, 104, those are big ones. So 10, 10, 10, 10, and 10, nope, 100. 470 and 470. So those are all correct according to this, at least. And I'm not gonna worry about it too hard. Earphone. Let's open these up. Time is it? 2:14. Hell, I might not even have time to solder. There is the earphone jack. Or well, the earphone. Straight up. Earphone. There is a screw for the dial, and there is a screw for the gang. The gang's in here. Isn't it? Did I separate them? Earphone. Screw. 2 screws for the gang. Okay. There are 2 little bitty screws in there. And then there's a longer screw in there. Okay, so I have all of the parts. Now I can move on to the next thing. Save the box that this kit came in. It will be used on further pages. I looked at page 32. It's not on page 32. It's on page 61. Because I was like, how is it gonna get used? It's not on page 32. I read this entire page. I read this entire page. It's not on there. It's used in like the very last step as what do they call it? Baffle. It's used as a baffle. So it's in the very, very, very end of the book, but identifying resistor values. I found this particularly helpful. I didn't know how to basically read a transistor before. I know I've taken apart a lot of small mechanical things as a child, and I really liked playing with these things, or at least taking them off and just looking at them, because they look like itty bitty batteries. But I used to basically destroy things and not know how to put them back together, so it's fun. Alright, so using the following information as a guide in properly identifying the value of resistors, you've got the first band is the first digit, and the color of it refers to what the actual value of the digit is. Second band, same deal, same color value as well. And then the multiplier is how many times you multiply that number by to come up with your final digit. And then the resistance tolerance, which is all these different resistance tolerances. And like I was saying earlier, some of these are put on this thing backwards, so I was confused about that. But gold, they all end off with gold, so they are all. That actually looks like it says plus or minus 5%. So plus or minus 5%. Kind of the same deal with the capacitor values. Identifying capacitor values. Capacitors will be identified by their capacitance value in picofarads, nanofarads, or microfarads. Identified by little p, big F, little n, big F, or mu, big F. Most capacitors will have their actual value printed on them. Some capacitors may have their value printed in the following manner. The maximum operating voltage may also be printed on the capacitor. Electrolytic capacitors have a positive and a negative electrode. The negative lead is indicated on the packaging by a stripe with minus signs. That is that side right there. It's only on one side. And possibly arrowheads. So it might even have pointers on it. These kind of have pointers on them. Pointing on that side. Also, the negative lead of a radial electrolytic is shorter than the positive one. So if I flip it over, you can see the short ones are all on the right side. That one's crossed over, so it won't pop out, but blah blah blah. Same deal as the resistors. First digit is the first digit. Second digit is the second digit, and the third one is the multiplier. It also could potentially have a letter on the side which would indicate its tolerance. M indicates tolerance of plus or minus 20%. I work in a machine shop. I speak in thousands. Blah blah blah. Blah blah blah. Okay, so that stuff was particularly helpful to me in at least initially starting the process. So, introduction. The Elenco Superhet 108C AM/FM radio kit is a super heterodyne receiver of the standard AM amplitude modulation and FM frequency modulation broadcast frequencies. The unique design of the Superhet 108 allows you to place the parts over their corresponding symbol in the schematic drawing on the surface of the printed circuit board during assembly. This technique maximizes the learning process while keeping the chances of an assembly error at a minimum. It is very important, however, that good soldering practices are used to prevent bad connections. The soldering guide should be reviewed before any soldering is attempted. The actual assembly is broken down into 9 sections. The theory of operation for each section or stage should be read before the assembly is started. This will provide the student with an understanding of what that stage has been designed to accomplish and how it actually works. After each assembly, you will be instructed to make certain tests and measurements to prove that each section is functioning properly. If a test fails to produce the proper results, a troubleshooting guide is provided to help you correct the problem. If test equipment is available, further measurements and calculations are demonstrated to allow each student to verify that each stage meets the engineering specifications. After all the stages have been built and tested, a final alignment procedure is provided to peak the performance of the receiver and maximize the Superhet 108's reception capabilities. This kind of goes backwards. IC or transistor audio amplifier, figure 1, section 1, section 2, AM detector AGC, section 3, second AM IF amplifier, section 4, first AM IF amplifier, section 5, AM mixer, AM oscillator, section 6, FM detector, 7, second FM IF amplifier, section 8, first FM IF amplifier, section 9, FM RF amplifier, FM mixer, FM oscillator, and AFC. Not going to be worrying about the FM radio right now, obviously, just doing the AM radio at this point. The purpose of Section 1, the audio amplifier stage, is to increase the power of the audio signal received from either detector to a power level capable of driving the speaker. The audio amplifier is IC or transistor version. Section 2 includes the AM detector circuit and the AGC automatic gain control stage. The AM detector converts the amplitude modulated IF intermediate frequency signals to a low-level audio signal. Let me read that again without the parentheses. The AM detector converts the amplitude modulated IF signal to a low-level audio signal. The AGC stage feeds back a DC voltage to the first AM IF amplifier in order to maintain a near constant level of audio at the detector. Section 3 is the second AM IF amplifier. The second AM IF amplifier is tuned to 455 kilohertz and has a fixed gain at this frequency of 50. Section 4 is the first AM IF 2 amplifier, which has a variable gain that depends on the AGC voltage received from the AGC stage. The first AM IF amplifier is also tuned to 455 kilohertz. Section 5 includes the AM mixer, AM oscillator, and AM antenna stages. When the radio wave passes through the antenna, it induces a small voltage across the antenna coil. This voltage is coupled to the mixer or converter stage to be changed to a frequency of 455 kilohertz. This change is accomplished by mixing, heterodyning. When I read heterodyne, I think like, what is it? Cysteine or dyne? I can't remember what it is, but the company in Terminator movies that's like, it takes over the world with machines. Heterodyning is this change is accomplished by mixing or heterodyning the radio frequency signal with the oscillator signal. Section 6 is the FM radio detector circuit. The FM ratio, I said radio, didn't I? Section 6 is the FM ratio detector circuit. The FM ratio detector has a fixed gain of about 20. Section 7 is the second FM IF amplifier. The second FM IF amplifier is tuned to 10.7 megahertz and has a set gain of approximately 20. The 3 decibel bandwidth of this stage should be approximately 350 kilohertz. Section 8 is the first FM-IF amplifier. The first FM-IF amplifier is also tuned to 10.7 megahertz and has a set gain of approximately 10. It also has a 3 decibel bandwidth of 350 kilohertz. Section 9 includes the FM mixer, FM oscillator, FM RF radio frequency amplifier, AFC automatic frequency control stage, and the FM antenna. The incoming radio waves are amplified by the FM RF amplifier, which is tuned to a desired radio station in the FM frequency bandwidth of 88 MHz to 108 MHz. These amplified signals are then coupled to the FM mixer stage to be changed to a frequency of 10.7 MHz. This change, as in AM, is accomplished by heterodyning the radio signals, the radio frequency signal with the oscillator signal. The AFC stage feeds back the DC voltage to the FM oscillator to prevent the oscillator from drifting. Each of these blocks will be explained in detail in the theory of operation given before assembly instructions for that stage. Oh my goodness, construction. Okay, introduction. Another introduction. The most important factor in assembling your Superhet 108C AM/FM radio kit is good soldering techniques. Using the proper soldering iron is of prime importance. A small pencil-type soldering iron of 25 watts is recommended. Giggle snort. The tip of the iron must be kept clean at all times and well tinned. I'm gonna take a little aside here to mention my particular device. I have a Heiko, or Hacko, if you so choose. FX888D ESD safe, temperature controlled soldering station. It was probably $90, but for a soldering station that's pretty decent. This got reviewed well by multiple sources, so I have no idea what I'm listening to right now. Alright. Okay. Put these off to the side. In my research, it said that there's nothing wrong with a small pencil-type soldering iron of 25 watts, but apparently if you're going to be doing any significant soldering, it's better to have an actual soldering station where you can I don't know, not burn yourself, not burn your table. Things and stuff. Whatever. Personal preference, I chose to go with the more expensive, more longer lasting option, with better power. I think this has 70 watts. Yep, 70 watts. So, that, I chose that. But, yeah, that's what I've got. Blah, blah, blah. Solder. For my, keyboard kit, I'm going to be using Kester. Oh, what is this? 44 with quotes around it. Rosen core. 40 millimeter or 0.015 inch. Rosen core. And this is, where does it say? So this is supposed to be a 6337 mix. There it is. 6337 mix for the amount of lead and the amount of tin in it. Don't eat anything while you are soldering with lead solder. If you are going to eat afterwards, wash your hands. Don't wipe your mouth if you're using lead solder. You can, if you've got enough exposure, you can poison yourself. So, in this particular kit, it gives you a lead-free solder, which is cutely coiled up in there. This is 99.3% tin, and this is pretty thick solder compared to the stuff that I got on recommendation from the EV blog. The smaller the amount of solder, or the smaller the width of the solder, the easier it is to control how much solder is going on to whatever you're soldering. So that I learned from the EV blog. This lead-free solder, it takes more heat to get that, to get it to melt. Its melting point is higher than lead solder. But there it says right there, for many years, leaded solder was the most common type of solder used by the electronics industry, but is now being replaced by lead-free solder for health reasons. This kit contains lead-free solder, which contains 99.3% tin, 0.7% copper, and has a Rosen flux core. That's another part, is the flux, but watch the EV blog videos. They tell you everything, at least from a beginner's point of view, everything you could want to know about this stuff. It goes into very good detail. Lead-free solder is different from lead solder. It has a higher melting point than lead solder, so you need higher temperature for the solder to flow properly. Recommended tip temperature is approximately 700 degrees Fahrenheit. Higher temperatures improve solder flow but accelerate tip decay. An increase in soldering time may be required to achieve good results. Soldering iron tips wear out faster since lead-free solders are more corrosive, and the higher soldering temperatures accelerate corrosion. So proper tip care is important. The solder joint finish will look slightly duller with lead-free solders. Use these procedures to increase the life of your soldering iron tip when using lead-free solder. Keep the iron tinned at all times. Use the correct tip size for best heat transfer. The conical tip is the most commonly used. Conical may or may not be the most commonly used. The EEV blog suggests a chisel tip that happens to be a chisel tip, which is nice. And that's saying, just watch the videos. Makes it easier, apparently. We'll find out. Use the correct tip size for best heat transfer. I read that already. Turn off iron when not in use, or reduce temperature setting when using a soldering station. Tips should be cleaned frequently to remove oxidation before it becomes impossible to remove. Use a dry tip cleaner or tip cleaner. If you use a sponge to clean your tip, then use distilled water. Tap water has impurities that accelerate corrosion. I'm glad that this told me that, because it does not say anything on here. I do happen to have distilled water, because I have distilled water. But I left this in the package because it's still got that moist. It hasn't crusted up yet. I'm going to leave that in there for now. It also came with the metal cleaning stuff, so you can do that if you want. Besides that, it's already cracking. That's cool. It's not that important. Safety procedures. Always wear safety glasses or safety goggles to protect your eyes when working with tools or soldering iron. And during all phases of testing, be sure there is adequate ventilation when soldering. I've got a window right behind me with a fan in it too. I've got another fan over there if I want to blow solder smoke away from my face. Oh, this is lovely. Do not hold solder in your mouth. I know how tempting it can be. Don't put it in your mouth. Solder is a toxic substance. Wash your hands thoroughly after handling solder. Anytime you handle solder, whether you're actually soldering or if you just touch it like this, wash your hands afterwards. Can't stress that enough. You will very likely poison yourself. Locate soldering iron in an area where you do not have to go around it or reach over it. Keep it in a safe area away from the reach of children. I don't have to deal with children here. My door is also closed so that cats can't come in here and walk all over my shit while I'm doing stuff, so that's good. Assemble components. In all of the following assembly steps, the components must be installed on the top side of the PC board unless otherwise indicated. The top legend shows where each component goes. The leads pass through the corresponding holes in the board and are soldered on the foil side. So, goes in this side, whatever it is, whatever, goes in this side, they poke out on that side, and you solder them on that side. Et voila. Do not use acid core solder, only use rosin core solder. Rosin is essentially resin, I guess. It's from trees. What good soldering looks like? A good solder connection should be bright, shiny, smooth, and uniformly flowed over all surfaces. Solder all components from the copper foil side only. That is this side. Push the soldering iron tip against both the lead and the circuit board foil. Apply a small amount of solder to the iron tip. This allows the heat to leave the iron and onto the foil. Immediately apply solder to the opposite side of the connection away from the iron. Allow the heated component and the circuit foil to melt the solder. Soldering iron, solder, foil, blah blah blah. Allow the solder to flow around the connection, then remove the solder and the iron and let the connection cool. The solder should have flowed smoothly and not lump around the wire lead. Here is what a good solder connection looks like. From the side, orthographic view. Perfectly 90-degree angle connection there. Types of poor soldering connections. Insufficient heat. The solder will not flow onto the lead as shown. It just lumps around it. It's poopy. So clearly not doing it right. Insufficient solder. Let the solder flow over the connection until it is covered completely. Use just enough solder to cover the connection. You don't want to use too much. Excessive solder could make connections that you did not intend to between adjacent foil areas or terminals. Solder bridges occur when solder runs between circuit paths and creates a short circuit. This is usually caused by using too much solder. To correct this, simply drag your soldering iron across the solder bridge as shown, and that should break it. Are we gonna solder yet? Not yet. We're gonna test the diodes and test the resistors. Semiconductor parts familiarization. This section will familiarize you with the proper method used to test the transistors and the diode. Transistor test, NPN and PNP. Refer to the parts list and find a NPN transistor. Refer the figure J, page 16, for locating the emitter, base, and collector. It says page 16. I don't know if I trust it. I don't know. There's stuff over here. Using an ohm meter, or in this case, a multimeter, connect the transistor as shown in test A. Emitter, base, and collector. I'm gonna actually need batteries to put into this. That thing pops off. Super easy, but it also goes back in super easy. It's okay. I have to unscrew this. Yay. Alright, give me a second. I forget what kind of batteries it uses. Hell, I might not even get to solder today. This is more a review of the kit and its usefulness and ease of use and level of information. It's more a review of the kit itself than, I don't know, a review of soldering? I don't know. Oh, there we go. Oh, well, that would be why then. One of them is popped out. The AAA's anyway. Alright, well, does it turn on? Yeah, it turns on. Okay, I'm gonna put this back on. I just grabbed a couple random batteries. I didn't even look at that. It says on the back, which is terribly convenient, 2 AAA batteries. Good enough. Okay, so super sharp points. It's not a bad idea to keep this. I'm actually going over my time. Well, now I'll be able to solder. I'm gonna go over these transistors, and then I'm gonna stop for now. But I'm probably gonna do this again later tonight because I've got it all set up. This is the manual for the multimeter. The black one, always goes into the COM one. It's got nice banana plugs, so you can't touch anything. Let's grab the P&P. I'm gonna go back to the front here and find NPN, P&P. We've got any one of these little guys. This one is 904, 3904. See if I can grab something different. Hey, this one says 550. It's a P&P. It's an NPN. We'll take a look at these two. For now, I'll probably check the other ones out later on, but for now, this. And then this other guy is gonna plug into my ohm because we're testing resistance. And this is an auto-ranging multimeter as well. So we're gonna switch my doodad here to ohms. And between my two fingers on the opposite sides of my body, I have decreasing resistance. 13, 12 and a half, whatever. So this one is the NPN. This one would be, let's see here. I think this connects over two of these leads and then to this third one over here. Which is giving me 29.3, 30, if I can keep the lead on there. $29.3. That's holding pretty steady. Oh, I see. The emitter is this one on the left. The middle one is the base, and the one on the right is the collector. That is what that says. EBC. Switch it to the collector. Your meter should again be reading That's in. This might be the other kind. Grab an NPN. You know, I don't know if this is the NPN or the PNP. I forgot already. NPN is the 904. That's the one I'm playing with right here. 904. Connecting it like here. This. The COM is negative. That's negative. So yeah, I'm doing it right. This is the NPN. And I'm connecting it across both. The positive lead I'm connecting across the base and the collector, and I'm touching the negative to the emitter, and I'm getting something around 30, 29.5, 28.5. And if I connect it to the other side. It's giving me 0. Low resistance. Using an ohmmeter, connect the transistor as shown as test A. Your meter should read a low resistance. Switch the lead from the emitter to the collector. Your meter should read a low resistance. So, I don't know, maybe 30 is low. But if I do this, connect this to the... I gotta put the negative one in the middle. Yeah, I'm gonna bend this bit. Alright, negative one going on the middle. Positive one on that. And I'm not getting jack shit. High resistance. Connect the transistor as shown in test B. I'm popping this fucker around. Stay down. I'm getting nothing. I mean, 0 is not a high resistance. Using an ohm meter, set to set the mega ohms. Could be kilo ohms. I can see where it switches. Well, maybe I'm doing it backwards, and it's supposed to be like this. In which case, yeah, but it doesn't. Clearly, I probably need to look at page 16. Diode. Mount E lead is in. Okay, so top left on the flat side. Here's the flat side. This side over here. This is the emitter. This is the base, and that's the collector. Well, I'm confused because that's the flat side. That's the emitter, that's the base, and that's the collector. And I'm getting the opposite of what this is. This is the 904. Let me take a look at this other one. This is supposed to be this. Nothing. Nothing. Basically nothing. And then the opposite is... that's the one I just did. This is difficult. Fuck it. I'm getting nothing. Still getting nothing. Well, I don't know. I'll have to figure it out another time because I think I am out of time for now. So we'll come back to this sometime tonight and figure out what this is supposed to do. I'll read it over before I start up again and figure out what the problem is and why I am not understanding this right now. Yeah.